Hello guys, Ankesh this side again. Let's continue with our previous video or the previous task that we were doing, connecting the esp32 using JTAG. Last time in the session we were able to connect the JTAG and we were able to flash the program onto the esp32. Now going forward, next thing that we are supposed to do is debug the code that we loaded onto the esp32 using the GDB. So this video might be in parts because there are certain logic which I need to explain in this video, and it might not be possible for me to compress everything in one single video. It will become quite boring. So we'll do this video in parts. For now, we are going to run the GDB. I'm going to tell in this video what exactly you need to do to access the core using GDB, because ESP32 consists of many different cores. Different variants come with different models of RISC-V, 10 Celica processors in different combination, different clock speeds. So they have a dedicated system of GDB designed for each and every type of processor variant which they have put in the market. So the one which I have with me, I'll show you for that. So you'll get an idea that what you are supposed to do when you have to do the same task on your own processor. So let's go ahead. So the command last time, first we have to connect the JTAG with our ESP32 using this command that we have already covered in the previous video. So I'll simply run and connect my ESP32 processor using the esp-proc JTAG. Here you can see I have connected it here, esp-proc and JTAG. I think I misplaced some wires while showing it to you. Yeah, now it is connected. Once the GDB is once the JTAG is connected, next thing that we are supposed to do is get to GDB. So I'll open one more terminal for this. Yeah. So in my case, for locating the GDB which can run the debug on your ESP32 processor, you have to find a folder in your system which usually resides in the home directory, and it is a hidden folder. If you have carried out the default installation, then the name of the folder is .esp32. I'll simply do one ls-la in my system. So in this, here this is the folder .esp32. So we need to go inside this folder and then we'll do ls .esp32 this, and we have these folders inside the .esp32 folder. We have to go inside tools. So we'll quickly navigate to tools. Then inside tools, we need to find the relevant folder for us. Then it is the GDB folder that we need to go inside. And in my case, it is extensa_esp_elf. So if you are using a core that utilizes a RISC-V CPU internally in your ESP32, then you have to go inside the RISC-V32-elf-GDB. But for us, for the variant that I have, I've got 10 Celica cores in this ESP32, so I'll select extensa-esp-elf-GDB. So that will be go one more down, the folders. Go inside this folder again. So here you'll find bin folder. Go inside the bin folder where we'll find the GDB executables. So in this you have to use the first one, the extensa -esp32-elf-gdb. So while running this file, what I'll do is, for running this file, in case of Linux I'll do dot, then backslash, then I have to give the name of the executable. Once you have given the name here, then the next thing that you're supposed to do is provide the binary or the elf file, which is either there on this ESP32 already, or in fact even if it is not there, then you have to provide basically the elf which you are supposed to load onto the ESP32. So in our case we flashed the uart program, which resides inside the example folder of my ESP toolchain installation. So I'll provide the path to that file, which is /home/ then esp_5.5 tidf, then examples, peripherals, uart, tasks, and inside this build folder. And inside this build folder I'll find the elf file. So use this elf to start the GDB. It is saying extensa elf esp elf gdb, no such file or directory. Why so? Okay, let's run it directly. Okay, I'll take a pause here and I'll get back with the solution. So hey guys, I'm back again. Actually I was giving wrong command last time. I forgot to put ESP32 here. I was putting ESP. That's why I was getting wrong output. Anyways, it will run. So for removing this dot and backslash option, what you can do is you can run this command, basically export the path so that you don't have to do it. It will be added to this terminal, and till you are operating in this terminal, this path will remain active, and you can directly access this program by typing the name extensa-esp32-elf-gdb. So I have already exported this path here, and now I can simply do extensa-esp32-elf-gdb and then provide the path to my elf file, which is inside the esp5.5 toolchain folder. So I'll again go there, /home/ it's /esp_5.5 espidf, then examples, then peripherals, then uart, then uart rx tasks, then build folder, and then the elf file. So see, the GDB has started as intended. Next thing that we have to do is connect to the ESP32 processor. So for that we need to first check that on which port we connected our JTAG interface. So TCL is on 6666, Telnet is on 4444. Last time we used Telnet to flash the program, and GDB server is running on 3333. So we will write here target remote localhost 3333. So now we are inside the code. It is saying an address in ESP CPU, wait for interrupt. So internally it is waiting for an interrupt because we actually flashed a UART RX program. So it is waiting for an interrupt to start the transmission. That is where it is held. So from here we can begin our debug process. I'll give you a basic walkthrough how you can start. So every program has a folder called app_main in case of esp32. So you can first go for the disassembly, that means disas of the app main. For that you can type disas and write the app_main. So you see these are the entries with their address headers, and the instructions are also listed next to the addresses here. So basically we get to see what exactly the processor is doing at each step using this, and we can very efficiently debug any kind of bug in our build using the GDB, using this process. So in this disassembly we can see that there are multiple steps which are happening, and if you look closely, the function at 0x400D3BB5, a task is being created. And it is pinned to a core because ESP32 is a dual core processor, so it has an internal FreeRTOS function that provides an affinity to a task, that on which core of this ESP32 the task is going to run on. So suppose if there is such kind of function which is available, you can further disassemble the function itself. So what I will do, I will write disas and I'll copy this header and see, now I can see the instructions which were carried out inside this function call. Now if I want to go further deep down into it, say for example I want to find out what happens inside this, I'll copy this header here and I'll do this as, and I can see what it does inside this. Now suppose we already know that through the monitor terminal that at certain point our program stops. Say for example my program is stopping at heap caps malloc. For some reason there is some kind of heap violation that happens in the dynamic memory allocation, which results in core panic and my core resets. I already know that. So what I can do is I can put a breakpoint. How to put the breakpoint? You have to write breakpoint, write asterisk and provide the address. So I'll take this address here, copy it and paste it here. Okay, it is saying, let's see if I write B, yeah, So probably there's a difference in command. Probably in some other version of GDB the command might be breakpoint, but here I think it can be done by simply using B. So I have put a breakpoint at this particular location, and what I'll do, I'll put a breakpoint at this RX task here at this location. I'll copy this, I'll go down, I write B asterisk and this address, press enter. So I have put 2 breakpoints here. Now what I can do is I can again begin from the start. What I'll do monitor reset halt. Okay, now I am at the start. Next I'll do step. So again step, again step, again step. It's not able to find, so write continue. Now it will start at the breakpoint which we put there in the X task create section. Where did we put the first breakpoint? It is saying 0x400 D3BB2. Let's see if this is, oh, it simply reached the okay, because we have already started the program. So it has reached at the second breakpoint here. Why? Because we actually put the first breakpoint in a later part of our program, and the second breakpoint was put in the former part of the program. That's why it has hit our second breakpoint first, which is at 0x400 D3BB2. Now from here we can basically trace everything that it does. We can write a step. It will give us step-by-step execution. We can also do list, so we can do backtrace, and there's one more command that we can do, info what options do we have? All registers, decache, locals, record, main, shared library. I think info all registers. Yes. So this gives us the state of all the operating registers of esp32, and you can basically find out what each register is meant for doing. There are various states which are shown by various different registers. For example, this is our program counter here. PC simply stands for program counter. Then these are general purpose registers. Then we have states, thread ptr, verbose, sar, config d1, state 68120. This changes as the program goes forward, executes executes more tasks. So different registers are there. Each register name you will get on the left, for which you can find its function, and then eventually the value which it is holding, that will give you the present state or the present value. Accordingly you can find out in what state your processor is, what it is doing. And suppose if you are in a state where the processor is in an infinite loop, you can probably know from here that what is getting placed inside the register from the memory location or from the variable, and you can accordingly do the modification and rectify your program for making it work better. Yeah, so I did all the registers. I think if you simply do the registers, it will give you the the core registers which are needed for the proper functioning of ESP32. So here is a more concise list of registers. From where did it start? Info registers, I typed it here, and yes, these are the values. M0 and thread PTR. So these are quite important if you are doing the floating point operations, because ESP32 supports 64-bit double precision floating point numbers. So, but it doesn't do in a single variable, because it has only a 32-bit wide width of bus. So what it does is it breaks the 64-bit number into two parts. So F64R underscore low and F64R underscore high. So by getting the value in this registers, by fetching the value of these registers, you can basically find out whether your floating point operation is working properly or not, whether the numbers are getting combined properly or getting divided into two parts properly or not. You can find out from here, which happens quite often when you implement filters using ESP32. So in this way, you can further go ahead like step. We can do a continue, and it will start on the breakpoint 1, which is at a later stage of the program. Continue. See, now it stopped at the breakpoint 1, and the address is 40087351. And we can again do list to find out what it is doing. And we can again go inside this, do step, list, step. So this is how you can debug your program using JTAG and GDB on an ESP32. Okay guys, this is all for this particular session. If you have any queries, I am putting my email in the videos which I share. You can always send me a message, and I'll respond to it to solve your queries. I hope this session helps you out in your ESP32 programs and builds. Goodbye.